Hey, good morning, class. It's Mr. Copperthite here. Happy Monday. I hope that you had a great weekend. I'm sorry I'm not here in school today, but I'm sure that you are being very nice and very helpful to the substitute, and you are here watching this video lesson, so obviously you are already doing something right. So here you are. And I just want to let you know I've got your tests. I will be putting them into PowerSchool very shortly, probably tomorrow at some point. If not tomorrow, then definitely in the morning. Had a busy weekend, but no problems with that. Got most of your tests already graded, and for the most part, not bad. You just check PowerSchool and see how you did, and we'll go from there. Anyway, today we have a new topic that we're going to be doing today. We're going to be converting some numbers into scientific notation. So far, all we've done is we've taken numbers that are already written in scientific notation, and I'm going to use this format here. I just got to increase the font size. This is a little too small for you guys. There we go. That's a little bit better. So we've taken numbers that are written like 3.5 times 10 to the, and I'm going to use this kind of shorthand here, times 10 to the fourth. This is your standard scientific notation. I could use a superscript option. Actually, no, I'm going to do that. I take that back. I'm going to take this number here, instead of writing it like this, I'm going to edit it, and I'm going to write in my superscript 10 to the fourth. Right, so I have that option. Okay, so anyway, we've taken those numbers and we've kind of written them into standard notation. So in this case, this number here, this is going to be 3.5 times 10 to the fourth. Well, again, we could write 4 zeros, but since we already have a decimal place, we're going to write 3 zeros, so it's going to be 35,000 or 35,000. So 3.5 times 10 to the fourth is 35,000. Now, one of the things I want you to kind of get used to and kind of seeing is that if you see the power 10 to the fourth, right, you should expect that this number is going to be in the 10,000s. And why is that? Because what's 10 to the fourth equal? If you wrote 10 to the fourth and you wrote 4 zeros after it, that's going to have 4 zeros, which is worth 10,000. So 3.5 10,000s is 35,000. It's kind of a helpful trick to mentally prepare you for the value or the size of the number you're going to be writing. Anyway, so we're going to work today in just converting numbers from standard notation into scientific notation. So get ready to see some pretty small and pretty large numbers, but we will also see some comfortable numbers that are just kind of good for practice. All right, so let's go ahead and start with a couple of examples. So let's say we have the number 63. Actually, let's use a number I mentioned in class to some of you, that the sun, the star that's closest to us, is 150 million kilometers away. 150 million kilometers away. Let me just put a unit on that. Okay, km. If I can type, that'll help too, right? So 150 million kilometers. Now, we're going to take this number and we're going to convert this number into scientific notation. So what we're going to do this is we're going to have to kind of understand what it means in the first place to include it in scientific notation. So remember that we have two rules. Number one, we're going to use a power of 10, and number two, we're going to make sure that the factor is between 1 and 10. Now, the way we're going to do this is we're going to try to figure out in this number, where would I have to put a decimal point so that the factor is actually between 1 and 10. So obviously, if I put the decimal point here, it's certainly not going to be between 1 and 10, right? But if I go all the way over to here, right here, boom, if I put the decimal point right here, that spot is going to be between 1 and 10. We'll use a bigger there, right there, okay? If I put the decimal point right there, that is a number that's between 1 and 10. If I put it here, that's 15. If it's here, that's nothing, right? So we're going to kind of think about, all right, well, where does the decimal point have to go? Okay, so the question we're going to ask is, where does the decimal point have to go? Where does the decimal point have to go so the number is between 1 and 10, right? So we're going to kind of think of it that way. So in this case, the decimal point has to go, boom, right there. Now we're going to say, all right, that's our first question. Now the next question is, where was the decimal point before? And when you write the number again, and where does it have to go, or how many jumps does it have to make to get there? Okay, so the other, and I'll talk about the power in a second. So the decimal point, obviously, in this number is starting here. It starts here. And where has it got to go? Well, it's got to go here. That's its new destination right there. So how many places do I have to go to get there, right? So the one I'm going to look at this is I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Boom. All right, so I had to make 8 jumps that way to the left. Okay, 8 places to the left. So where does decimal point have to go? So how many places? How many places does the decimal point need to move, and which direction as well? The direction obviously will matter as well. Okay, so in this case, I had to move 8 places to the left. Now, here's what we're going to do. We're going to write the number in scientific notation. Now, we know that with the first number is going to be 1.5, okay? The factor is 1.5 because I got to put the decimal point, boom, right here. Now, once I put the decimal point here at 1.5, now all of those zeros that are after it, we don't have to worry about it, which is nice. The whole point of writing scientific notation in the first place is to eliminate all those nice place-holding zeros that we have to put so we can understand the value of the number, right? Writing 150 million requires a lot of zeros. Writing it in scientific notation, however, doesn't require any zeros, which is really nice. So writing 1.5, we're good to go. Now, the second thing we're going to write is, of course, we're going to write the power of 10, right? Well, what do you think the power of 10 is? Is the power of 10 negative 8 or positive 8? Well, if it's a very large number, it should be a positive power, right? So it's going to be positive 8. So 1.5 times 10 to the 8th is going to be our answer here. Now, positive or negative power, well, another way to look at it is this. If you move left, then that is going to be a positive power, right? Positive power of 10, that is, right? If you move left, you're going to have a positive power of 10. And of course, if you move right, which we haven't seen an example of yet, you're going to have a negative power. And again, you can kind of use regular common sense here as well. Don't be afraid to use common sense. We want it to stay common sense. We don't want uncommon sense. So if we have a very large number and we're starting with a very large number, when you convert it to scientific notation, you should think, yeah, it's going to stay a very large number. So we're going to make it so that the power is positive, right? So we have to kind of use that logic there as well. All right, so there's our first example. Let's do another one. Let's stick to the positive powers first. So let's say we had a number like, let's say the amount of, how about the amount of, the example that we did earlier in class, it was something along the lines of this. How many seconds have you been alive? Kind of example. And I don't remember the exact number out of here, but I know I could calculate it really fast. Let me do that really quick. Okay, so the number, so for you guys, it's 410 million. And for me, on my, I'll do mine in a second, for 410 million, so it's going to be this, 1, 2, 3, 4, 5, 6, right? For you guys, seconds. That's for your typical 13-year-old. If you're 14, obviously the number is bigger. Or if you are Mr. Copperthight's new age, which is 38 today, you are going to be, and I'm just punching this in the calculator right now, you are going to be, we'll do this one later, 1, 2, 0, 0, 0, 0, 0, 0, 0, 0 seconds, right? So we're going to have those kind of examples as well. All right, so let's do both of these. All right, so we're going to convert this first one. We'll convert this one to scientific notation, and we'll kind of use the same system. So first question, where does the decimal point have to go so we get a number that's between 1 and 10? So if we look at this number, it can't go here because, well, that's where it is, right? It's got to go between the 4 and the 1 right here to make this number between 1 and 10. Let me make that thicker. It's got to go right here, 4.1. So in other words, it's kind of got to go between the last two numbers. Generally, that's what's going to happen. When you have a number in scientific notation, you're going to want to put a decimal point between the last two numbers. Okay? Not as easy when we do the scientific notation for the smaller numbers. We'll get to that in just a second. So we're going to convert that way. So we're going to put the decimal point there. Now, the next question, how many places is that? So if the decimal point was here, and we're going to look how many jumps does it have to make. 1, 2, 3, 4, 5, 6, 7, 8 jumps. Okay, so it's got to make 8 jumps to the left. Sorry, my mouse got snagged up there a little bit. Let's draw that one arrow again. That way. There we go. So it's like 8 places to the left on that one. So again, we're going to write the number as such. So it's going to be 4.1 times 10 to the 8th power. Okay? So that's going to be that number in scientific notation. Now, if we do the time that, for me, 38 years of seconds in this case, we're going to put the decimal point where we would have to go. Again, just like kind of using this standard notation, standard format, just find the last two numbers that you have and put a decimal point there. That's where the decimal point is going to go. How many jumps is that? From the old location, 1, 2, 3, 4, 5, 6, 7, 8, 9 this time. So that means 9 is our power, so 9 places to the left, so 1.2 times 10 to the 9th would be that number, okay? So now the second question I have for you here, okay, if I just had you to look at these two numbers right here, this is the scientific notation for a 13-year-old person in seconds, and this is the scientific notation number for a 38-year-old in seconds, right? So how would you know which number is more? Not just because I told you that one's 13 and one's 38, but what's the kind of giveaway as to which of the numbers is higher than the other, okay? Well, in this case, it's the power of 10. So we're kind of comparing numbers. If we compare numbers in scientific notation, we start, the priority number one is to look at the power, right? So obviously if one of the scientific notation numbers has a higher power than the other, then that certainly is greater, right? So we would say 1.2 times 10 to the 9th is greater than 4.1 times 10 to the 8th. And the reason why is because 10 to the 9th is a higher power than 10 to the 8th. Even though the factor of what 10 put to the 9th here is 1.2 and this is 4.1, well, if the factors are, if this factor is bigger than this factor, but you got to look at the power. The whole number is bigger because the power of 10 is greater in this number than in that number. Okay, so let's do another example, one more example of converting, and then we'll kind of sum it up and kind of talk about what you're going to do in class today. Whoops, I hit the wrong thing. Let's insert a page. There we go. All right, so let's say we had a small number, something small, like the thickness of a human hair or something like that. I know that's an example I'd use in class. Let's use the thickness of a guitar string, of the E string on a guitar, which I believe is something in the neighborhood of 0.004 centimeters. I think it's something like that. Maybe not that small, but let's go with it. Let's go with that just in case, right? So we're going to convert this number to scientific notation. First off, this is a basic number, not a big deal to write this in standard notation. It takes as many digits to do it in both, right? So, but for purposes of example, let's make sure we can do it. So here we're going to kind of say the same thing. Where does the decimal point have to go? Well, and this one's pretty easy, right? Because right now it's less than 1. 0.004 is less than 1. So the decimal point's got to go somewhere to make the number between 1 and 10. So putting it here is going to be the correct answer, right? Putting it here after the 4, because that's the first place where you have a number that's they're going to be between 1 and 10. Another little shortcut here is put the decimal point after the first non-zero digit, right? So if I gave you and I'll give you an example after this, if I put there's more numbers after the 4, you're going to put the decimal point, boom, right after the first one, okay? But that'll raise another issue as well, which I'll bring up in just a second. So decimal point of the first non-zero digit, done. All right, how many places do we gonna have to move here to get this decimal point from where it is to where it needs to be? Well, in this case, it's gonna be 1, 2, 3 places, but this time we are moving to the right. So when we move to the right, we're making the number smaller. So we're going to be using, sorry, let me try it again. When we use the right, we're making the number bigger, but it's already a smaller number. So our system here is if we move to the right, we're gonna use a negative power of 10. Because again, we're dealing with a small number, so when I write it in scientific notation, I should be using a small power of 10, a smaller power of 10. So here, we're gonna write this. It's gonna be 4, there's no numbers after, so I can just write 4, times 10, in this case, since I moved to the right, it's gonna be negative 3 for my power of 10. All right, so that's nice and easy. Now, what if we had a number like this? This is our last example, I promise. 0.00000001093. Nah, what the heck, 932, okay. So we have a number like this. Now this number obviously is going to be much more convenient to write in scientific notation than it would be to write it in standard notation, as you can tell just by the amount of zeros that are in the number. Well, here we're going to use the same system. We're going to put the decimal point after the first non-zero digit. All right, well, where is that? It's right here after this 1. So the decimal point is going to move right here between the 1 and the 0932. Now, where was the decimal point? The decimal point was back here. How many jumps to get to its new destination? 1, 2, 3, 4, 5, 6, 7, 8. So we need number 8 today, right? 8 places, and this time, of course, we're moving it to the right. So because we're moving it to the right, we're going to have a negative power of 10. Now here, this is the part that's going to mess some of you up. Notice how I put the decimal point right here, but there's still a lot of numbers after it. Don't be tempted to think of it as standard notation where I just have to move the decimal point all the way to the right, because then I've got 10,932. That's not proper scientific notation. I've got to move the decimal point so that I get a number that's between 1 and 10. 1.0932 is how to do it, right? That's the number that we're going to have there. So it's going to be 1.0932, and that's going to be times 10 to the negative 8. And that is that. Okay, so now for class today, so you're going to have the following items at your disposal that I'm going to expect you to work on. So obviously, watch this video lesson all the way to the end. Thank you very much for that. I'm glad your attention span is good enough for that. You followed some examples. I hope you wrote some things down in your notes as well for this, because this is a little bit different than what you've done so far. So anyway, what you're going to do today is already posted on Google Classroom for you. It's a simple, straightforward. I want you to go in your record and practice journal. I want you to do the page that's listed on Google Classroom, which, if my memory serves correctly, is 226, but do make sure that you check Google Classroom. And I'm not assigning you any other homework tonight. There's even some extra record and practice journal pages that you may want to try, starting on page 223. I believe, again, you check Google Classroom for the correct page. I think that's right. And also, of course, you still have your outstanding work on Freckle. Post does say that you're getting a new assignment on Freckle. Some of you already had done that, but I'm going to make sure that I covered both. I think there's still one scientific notation assignment that I need to give you on there as well. So anyway, you got plenty to do. Use the period wisely. I'll check in with you tomorrow. I'll be back tomorrow, and I hope you don't miss me too much. And I hope that you have a wonderful day. Don't forget to be awesome, and I'll see you on Tuesday. Take care.